Lesson 15 is called Other Types of Functions, and it's pretty much just like kind of a preview of different types of functions that you'll see throughout algebra. So in 15.1, we're going to talk about absolute value functions. And absolute value is an operation that makes every number positive. It's used to describe the distance from zero. And it looks like this, where we have kind of two vertical lines that are surrounding our number or our variable. And those vertical lines are usually referred to like as the absolute value bars. So absolute value functions are functions that have absolute value bars around the input x. There can be some other kind of numbers and terms inside of the absolute value bars as well, but we at least will have x inside of them for sure if it's an absolute value function. So because the absolute value makes every number positive, the graphs look very specific. So here's 3 examples of what their graphs could look like. You see they kind of look like a V. They can be opening up or opening down, and they can be kind of placed anywhere amongst the graph. What can also change is kind of like the steepness of the V. So for example, like I could have an absolute value graph that like say starts here but goes up really steep like that. It can also get flatter, but the main thing that we want to know is just like the shape of an absolute value graph is like a V opening up or opening down, and the steepness of the lines can vary. So next we're going to graph this function using the table. So it's f of x equals -2 times the absolute value of x plus 8. So we have all of our input values already here. Those are all the ones in the x column. So in that middle column where it says work, we're just going to take each x individually and put it into the function where x is, and then we'll simplify. And then we're going to go through the entire table, and then we'll go back and graph it at the end. So my first x is 10, or -10. So I'm going to take that -10, I'm going to put it in the function right here. So it'll be -2, and then times the absolute value of -10 plus 8, and then we'll close the absolute value bars. And then absolute value bars are kind of like parentheses where we would simplify the inside of that first. So I would add these two numbers together first. So then it would become -2 times the absolute value of -10 plus 8 would also be -2. And then after that, I would take the absolute value of -2, which that turns everything, absolute value turns everything positive. So this would become -2 from that one that's out in front. And then the -2 inside the absolute value bars would turn into a +2. And then now finally we can multiply these two together. So -2 times +2 is -4. So this would become -4 right here. And that would be the output or like the y coordinate once we go to graph it. So remember that f of x and y, those are interchangeable. Okay, the next x value is -9. So we're going to pretty much repeat that same process, just put -9 in for x, so it'll be -2. And then the absolute value bars, -9 goes in for x plus 8. And then we'll add inside the absolute value bars first, so it'll be -2. And then -9 plus 8 is -1. And then we'll take the absolute value next. So this will become -2. And then the absolute value of -1 will turn it into a +1. So that we have -2 times +1. And now we can go ahead and multiply. And that would be -2. So we have a -2 over here now. And then keep going down the line. Next we'll use x equals -8. So this will be -2 times the absolute value of -8 plus 8 equals, and then we're going to add inside the absolute value bars first. So it'd be -2. And then -8 plus +8 is just 0. And then next we can take the absolute value. It turns everything positive. It's just going to leave 0 as 0. So this would become -2 times 0. And then now we can go ahead and multiply. And then -2 times 0 is just 0. So we end up with a 0 over here for that line. And then next we'll use -7. So I have -2. And then absolute value, -7 goes in for x plus 8. And then we'll add inside of the absolute value bars. So it'll be -2 times the absolute value of -7 plus 8 is a +1. And then for absolute value, it doesn't like change the sign. It just well, it can technically, but it doesn't always change it. It just makes anything that's inside of it positive. So since I already have a positive 1 here, it doesn't change it into a negative or anything like that. It just keeps it positive. So this would be -2 times +1, which -2 times +1 is just -2. So we end up with a -2 over here, and then now we just have one more input value, -6. So it'll be -2, and then times the absolute value of -6 goes in for x plus 8. And then I'll add inside of the absolute value bars, so this will be -2. And then -6 plus 8 is +2. I can take the absolute value +2, and that's just stays regular 2. So this would become -2 times 2. And then finally I can multiply -2 times 2 is -4. And then I end up with a -4 over here. So then now, when we go to graph our function, we have to remember that the first and the last column are like points now. So these are all of my x coordinates, and then these are the y coordinates that go with them. So if it's helpful, you can go ahead and like write them as a complete point in parentheses. So for the first line, it's -10 for the x, and then -4 for the f of x or the y. So -10, -4. The second line is -9, -2. The third line is -8, 0. The fourth line, -7, -2. And then the fifth line is -6, -4. And then that part is not like writing the point out is not necessarily like mandatory or anything like that. But if you have a hard time kind of pulling the points from the table, it's definitely recommended. So the first point, -10, -4, since we're starting, so we start at 0, 0, which is right here, and then we go left or right first. So since my first number is -10, I would go left 10 to right here, and then I would go down 4 to right here. So my actual point would be left 10 and then down 4, so I'm trying to erase the other point. So left 10, down 4 right here, and then for my second point, it's -9, -2, so I would go left 9 and then down 2 and end up right there. And then my next point, -8, 0, I would go left 8 and then I would not go up or down at all since the y coordinate is 0. And then the next point, -7, -2, I would go left 7 and then down 2. Left 7, down 2, and end up right there. And then for the last point, -6, -4, I would go left 6 and then down 4, and I would end up right here. So we have our points, and then here's where it's really good to know like what the shape of the graph is in general, regardless of what function you're working with. So we know that our graph is supposed to be shaped like a V. So when we go to connect our points, we know that they should kind of connect in like a sharp point rather than like a rounded point like you would with a quadratic or parabola. So from 8, we'll draw a line, or from -8, 0, we'll draw a line going down and to the left and then down and to the right. And then that's the graph of this function. And then we always draw arrows at the end of our graph just to show that it continues on forever, because these are not the only points for this function. It's technically like we could put in any amount of points that we want and the graph could keep going. Okay, 15.2 is about square root functions. So square root functions are functions that have a square root symbol, which looks like this over the input x. So square root functions, I only have one example of what they look like. They can look a little bit different, but I just wanted to put one on here. So they look kind of like half of a parabola. If you don't remember, a parabola is like shaped like this. So square root functions look like kind of half of that and turn sideways. So starting from here, going up like that. One thing that's important to know about square root functions is that they have a specific start point. So like instead of having arrows on both sides, a square root function would only have an arrow on one side, and this point right here would be a specific start point. And the reason is because you can't take the square root of a negative number. So our domain, like our x values that we can put in, are limited. So to get good at square root functions, it's helpful to know like what the first, first 12 perfect squares are helpful. And so this table is here. I would definitely save it and get comfortable with it. It's not only helpful for this section, it's helpful for a lot of different things in math. So I'll read through the first few. So the square root of 1 is 1, because 1 times 1 would be 1. Square root of 4 is 2, because 2 times 2 is 4. Square root of 9 is 3 because 3 squared is 9. Square root of 16 is 4 because 4 squared is 16. Square root of 25 is 5 because 5 squared is 25, and so on. So keep this table, save it, have it like somewhere you can like easily refer back to. Okay, next we're going to graph the function with the table again. So we have f of x equals 2 times the square root of x minus 1 plus 4. So we have all of our input values again on the left. Those are the different numbers that we're going to put in for x, and then we'll show our work in the middle. So we'll start with x equals 1. That number is going to go, like I said, right there where the x is in the function. So it'll be 2. And then that little like kind of check mark looking symbol, it's called a radical. So this is called a radical. Sorry, that doesn't really look like a C, but it's a C, so radical. Okay, so we put 1 in for x, so we'll put the 1 right here. And then minus 1, and then the plus 4 is outside of the radical, and that does matter, it does make a difference. Okay, so now the first step is to simplify inside the radical. It's kind of like parentheses first. We're simplifying like groupings first. So we'll do 1 minus 1 as our first step. So this will be 2. And then our radical, or the square root of 1 minus 1 is 0. And then plus 4 after. And then next we can go ahead and take the square root. I didn't put the square root of 0 on our table, but the square root of 0 is just 0. So this would become 2 times 0. And then plus 4, because the square root of 0 is just 0. And then next we have multiplication and addition, so we would multiply first. So 2 times 0 is 0, and then plus 4. And then now we can finally add 0 plus 4, and that gives us an output of 4. Okay, so we'll keep repeating that process, but with just our different x values. So next we have a 2 going in for x. So this would be 2 times the square root of 2 goes in for x right there, and then minus 1, and then the plus 4 outside of the radical. So we'll subtract inside the radical first. So it would be 2. Sorry, not changing. So 2, and then times the square root of 2 minus 1, so that's 1, and then plus 4 outside the radical. And then we would take the square root of 1 next. Square root is kind of like exponents in terms of order of operations. So first would be parentheses, or like stuff that's grouped together, and then next would be like exponents or a radical. So we would take the square root of 1 next, which is 1. So this becomes 2 times 1 plus 4. So this square root of 1 just became this 1 right here. And then next we have multiplication and addition. So we would multiply first. So it would be 2 times 1, which is just 2, and then plus 4. And then finally we can add 2 plus 4 to give us 6. And then same process, new x value. So we'll do x equals 5. So this will be 2 times the square root of 5 goes in for x, that first number inside the radical, and then minus 1, and then plus 4 outside the radical. And then we will subtract inside the radical first. So we'll do the 5 minus 1. So this will be 2. And then times the square root of 5 minus 1, so that would become a 4 right there. And then we would keep the like plus 4 outside the radical. And then next we would square root. So this would become 2, and then the square root of 4 is 2. And then plus 4 at the end. So what we did right here is we took the square root of 4, and that became this 2 right here. And then now we have 2 times 2 plus 4, so we would multiply next. So we would do 2 times 2 is 4, and then we'd have to add another 4 to it from that 4 at the end. And then now we can finally add, so 4 plus 4 is 8. And then one more time with our last x value, which is 10. So we'll do 2, and then we'll put 10 in for x, and then minus 1, and then plus 4 after the radical. So we'll subtract inside the radical first. So this will become 2 times the square root of 10 minus 1, which is 9, and then plus 4. And then next we'll square root. So the square root of 9 is 3. And you can just, again, you can keep referencing like this table up here if they're not coming like right away. You can always have this in front of you. So like the square root of 9 is 3. So when I take the square root of 9, I'll just replace that number with 3. So it'll become 2 times 3 plus 4. So took the square root of 9, put a 3 there instead. And then next I would multiply. So 2 times 3 would give me 6. And then I would need to add the 4 last. So 6 plus 4 would be 10. And then that's my last output value. Okay, and then remember with your table, the numbers on the left, those are all like the x's from your points, and then the numbers on the far right side, those are, they say f of x, but remember f of x and y are the same. So I'm gonna go ahead and just write the points really small off to the side because I didn't leave myself as much space, but the first line, the x is 1, the y is 4, the second line is 2, 6, the third line is 5, 8, and then the fourth line is 10, 10. So 1, 4, I would start from the origin right here, and I would go right 1 and then up 4, so that would bring me right here. And then the second point, 2, 6, I would go right 2 and then up 6, that would bring me right here. And then the third point, 5, 8, I would go right 5 and then up 8, that would bring me right here. And then the fourth point, 10, 10, I would go right 10 and then up 10. So that would bring me all the way up here to the corner of the graph. And then when we connect it, here's where, again, it's really important to know like the shape of the graph. So when I see these points, it's really tempting to go like this and connect all the way through because that's what we do most of the time. But remember with square root graphs, there's like this very specific start point, and it happens wherever like the inside of the radical is 0 because you cannot take the square root of like any smaller number basically. So in our very first line right here, we ended up with the square root of 0. So that very first line is going to create our starting point, which it was 1, 4. So 1, 4 is going to be where the function kind of starts and then goes from there. We won't have any arrows like extending kind of to the left of that point. So we'll start at 1, 4 and we'll go to the right like that. Okay, moving down to 15.3, this is called cube root functions, and cube root functions are similar to square root, but cube root functions are functions that have a cube root symbol over the x, which that looks like this. It looks just like the square root, except for it has a little 3. So a cube is what happens when you raise a number to the third power. So for example, 2 to the third power, you would read that as 2 cubed, like the 3D square, that's the word. And then 2 to the third power, or 2 cubed, means 2 times 2 times 2, which is 8. Because 2 times 2 is 4, and then times the third 2 is 8. So cube root functions look like this. They kind of look like a little snake. They're not like square root functions in that they don't have like a specific start end point. They just kind of continue in both directions forever. And then I included a cube root table on here as well. It looks like I actually forgot to put the little 3s, so I'm going to add them in here. These should all have little baby 3s, and I think I just forgot to type them. So I'm going to add them in now. So the cube root of 1 is 1, the cube root of 8 is 2, the cube root of 27 is 3, cube root of 64 is 4, cube root of 125 is 5, and then cube root of 216 is 6. And then because you're multiplying a number 3 times as opposed to just 2 times, you can also take the cube root of a negative number. You can't do that with a square root. So the cube root of -1 is -1. The cube root of -8 is -2. The cube root of -27 is -3. Cube root of -64 is -4. Cube root of -125 is -5. And then the cube root of -216 is -6. So because you're able to take the cubed root of a negative number, that's why the graph continues in both directions forever, as opposed to with square roots, you can only take the square root of a positive number, and that's why the graph only goes in one direction. Okay, so another table I would recommend definitely saving to kind of like refer back to. I'll add the little like 3s for the cube root to the printable version before I post this, so if you need, I'll have that part fixed if you print them. Okay, so we're gonna graph the table, or yeah, graph the function with the table again. So this time the function is f of x equals the cubed root of x. So I have all my input values on the left. Each of my x's are gonna go in the radical right here, and then after I take the cubed root, I'm going to add 6. So my first x is -8. So this is gonna be the cubed root of -8. I'm gonna make this a little bit bigger. So the cubed root of -8 goes in for x, and then plus 6. Same thing as before, where we would simplify the radical first. So I would go ahead and take the cubed root of -8. And if you're not sure what that is, remember that's why we have the table. So to find it, you would go and you would find where is the cubed root of -8, and then the number beneath it is what it's equal to. So the cubed root of -8 is equal to -2. So this would end up being -2. Plus 6, and then one more time the -2 came from taking the cubed root of -8. And then from there we can just go ahead and we can add those numbers together. So -2 plus 6 is 4. So this would end up being a 4. And then next we'll use x equals -1. So it'll be the cubed root of -1 and then plus 6. I'm not going to keep like switching back and forth between the table, but just know you can reference the table to find whatever cubed root you need. So we put in -1 for x, and then the cubed root of -1 is -1. So it'd be -1, and then the plus 6. And then -1 plus 6 is 5, so this would be a 5 over here. Next we'll put in 0, so this will become the cubed root of 0 goes in for x, and then plus 6. Any root of 0, cubed root, square root, fourth root, fifth root, whatever it is always 0, because if you multiply 0 by itself over and over again, it's going to keep being 0. So square root of 0 is 0, cubed root of 0 is 0, and so on. So the cubed root of 0, once we simplify that, it's just going to be 0, and then plus 6. 0 plus 6 is 6, so this will be a 6 over here. And then next we'll do x equals 1. So this will be the cubed root of 1, and then we will simplify, or sorry, after the cubed root of 1, it'll be a plus 6 from the original function. And then we'll simplify the cubed root of 1, which is just 1, because 1 cubed is just 1 times 1 times 1, which is still 1. So it would be 1 plus 6. 1 plus 6 is 7, so this will be a 7 over here. And then the last input value is 8, so we'll put an 8 in for x, so this will become the cubed root of 8. And then plus 6. So the cubed root of 8 is 2, because 2 to the third power equals 8. So this will end up being 2 plus 6, and then 2 plus 6 is 8. So this ends up being an 8 over here. So we have all of our x's for our points. We have all of our y's now, and then we'll just kind of put them together. So from the first row, it's -8, 4. From the second row is -1, 5. The third row, 0, 6. The fourth row, 1, 7. And then the fifth row, 8, 8. Okay, so for our first point, -8, 4, from the origin, I'm going to go left 8, then I'll go up 4. That brings me right here. And then the second point, -1, 5, I'm going to go left 1 and then up 5. That would bring me right there. Third point, 0, 6, I do not go left or right at all because the first number is 0. I just go up 6. That would bring me right there. 1, 7, I'm going right 1 and then up 7. That would bring me to right there. And then last point, 8, 8. I'm going to go right 8 and then up 8. So that would bring me right here. Okay, and then before we connect the points, we just kind of want to reference what the shape of the graph should look like so we draw it correctly. So we have the picture up here, And you can see it kind of like snakes through the middle like that. It's like nice and curved, no straight lines or anything like that. I'm pretty bad at drawing these though, so I will do my best, but I don't know why I always have a hard time drawing these like pretty. So like I said, it starts off a little bit flat and then it snakes through the middle like that. Okay, it wasn't that bad. May have overreacted. But like I said before, and this is like in regards to all of the functions, absolute value, cubed root, and square root, it's very helpful to get comfortable with what each of the shapes are. So like cubed root is kind of like this little snake shape right here. Square root is that one where it starts at one point and it just shoots in one direction. And then absolute value is that V shape, whether it opens up or opens down.